All right, so how do we do this? Well, the first thing we need is we need to put our forces on. And what we're going to have here are these forces. And these are all supposed to be acting from the center. I drew that one bad. So if we're trying to figure out how to solve this problem, we need to do, for each sphere, we need to do both sigma fx and sigma fy. And essentially, we've got one force tension that's in 2 dimensions. We can break tension down into both a y component and an x component. So if we're going to set up our sum of force equation with this being the y direction and that being the x direction, Fe is a wholly x force. So I'm going to call the left negative. So I have Fe plus Ft, but not all of Ft, just Ftx. And in the y dimension, I'm going to have this. Oops, didn't need to copy that again, replacing that. Fg is a wholly y force, and we'll have a part of Ft. And that's what we get. So what about acceleration? Do we know that? Well, these spheres are hanging at rest at equilibrium. So we have negative Fe plus Ftx equals 0, because acceleration is 0. All right. So now we can start plugging equations in and start trying to solve these. Our first step is going to have to be to do some trig to figure out what Ftx and Fty are. How can we figure out the trig we need? Well, we know that this is 0.68 meters. If we knew one other side, we could figure out this angle at the top, and we could do a little bit of trig. Well, do we know another side? We do, because we know that this whole thing is 0.17 meters. So that means that this is 0.085 meters. We now basically need to find the angle, and I'm going to use the idea that the sine of this angle is 0.085 over 0.68. So that tells me that sine theta is 0.125, and theta is 7.18 degrees. Okay, so now that we have that, I'm going to rewrite this in terms of sine and cosine of theta. The negative of electric force is going to be added to Ft. And since this is Ft and this is theta, that's Ftx, that's Fty. We can see that sine theta is Ftx over Ft. Cos theta is Fty over Ft. So those two little equations, if I rearrange this one, I'll see Ftx is Ft sine theta. And Ft sine theta equals Fe. Fg goes with Ft cos theta. So Ft cos theta is Fg. Okay, So now we just got to plug in equations for FG and FE, and we should be almost ready to solve these out. FT cos theta is K Q1 Q2 over R squared. That's Coulomb's law. Or FT sine theta, excuse me. And FT cos theta is mg. So what I'm going to do is I'm going to divide these two by each other to cancel out FT. And then everything here should be known to me except for Q1 and Q2. So I'm going to divide this by FT cos theta and this by mg. And what I end up with is tan theta is KQ1 Q2 over R squared mg. Tan theta is K. Since we know that they have the same charge, the problem said that, it's going to be KQ squared over R squared mg. So R squared mg tan theta is KQ squared. R squared mg tan theta over K, the Coulomb's law constant, is Q squared. So now I can just plug in numbers basically and solve this. To get Q. So the distance between the two was 0.17. The mass is 0.1. G is 9.8. And tan theta is, tangent of 7.18 is 0.126. And Coulomb's law constant is 9 times 10 to the 9th. So the charge must be 0.17 times 0.17 times 0.1 times 9.8 times 0.126 divided by 9 times 10 to the 9th. And then we'll square root that. And I've got 6.3 times 10 to the negative 7th. And that's my final answer.